Okay, good. Okay, so let me just. Right. Okay, column column vectors. Mm-hmm. Okay, before you continue, can I ask you a question? We try to let me try to write on this as well. So okay, so what you have done so far over here is you have um you have um done some vectors calculation mathematically, right? Okay, so um have you learned like different kinds of transformation?
Oh no, we haven't gotten there yet.
Oh, okay. So I think with the understanding in this vectors chapter, and especially this column vector. Okay, let me just choose wait with this column vectors with scalar. I think somehow you have built some basic understanding of the transformation chapter later on. Okay, so before you continue, probably, I think uh, I think they are linked. Okay, in a way, this is okay. So I think in the past we have learned like y equals to mx plus c, right? And then this is the equation of line, right?
Yeah.
Okay. So I'm just trying to let you know how your knowledge in column vectors or vectors will help you in your transformation chapter. So something like if this is the equation of the line, and then you are asked to draw or sketch the line on some graph papers, right?
Mm.
Okay. So similarly, you will. I'm not sure if you need to draw, but definitely definitely um you can kind of like I, I cannot say you solve vectors graphically. Actually, you can. Okay, actually you can. Okay, so let me just start with a pretty easy one. Okay, start with a pretty easy one. So let's start with 3a plus 2b. Okay, and instead of using this 7 8 I mean 8 7 and then minus 12 and 5, because these numbers are too large and I don't think we have, I think we have enough space, but just to for our convenience, I think we just play with smaller numbers. So it's because we want understanding more than the technical stuff of solving it. Okay, so
Okay.
um, okay, this is a very good tool for us to get the um, this x and y uh, out, x and y axis out. Okay, so if I have let's start with the 3 a plus the 2b. So let's say my A is the column vector for A is what do you want to pick? 0, 2?
Okay. Can.
Yeah.
Yeah.
So B is 1 and 2. Yeah. Just make things simple for us. So of course you need to label the axis first. Okay, there was no negative number, so I just ignored it. Okay, something like this. Okay. So for the column vector of A, right, 0, 2, so 0, 2, which is here. So this is your so this is in fact your OA lah. Alright. So
Okay.
this in fact is your OB. So 1 and 2, 1 and 2. 1 and 2. Okay. Okay. So if you have OA, so I can use different color, right? OA, and then this is your OB.
Okay.
So I can use this to represent, and use this to represent. Okay. So with 3A over here. So we'll give you, if you do it mathematically, so the 3 will go into it times, right? So it's 0, so it's 6. So you end up with 0, 6. So in a way, right, if you look at it from this, can you just move your cursor a little bit away?
Okay.
Yeah,
Oh.
thank you. Yep, that's good. Thank you so much. So if you use the 3 times this OA, right, this 0 and 2, so in a way, does it make sense to you? You just extend it vertically up 3 times. So you just repeat it. Second time, another time. So can you see that you put a 3 in front of your this vector A, basically you just 3 times it, and you will hit this, what's this point, which is 0, comma 6. In column vector is 0, 6. So that's how you get your 0, 6.
Okay.
Okay. So in a way, I'm trying to let you see the how you can relate the vectors to this, how you can like graph the vectors out. Okay. And in a way, you can solve the these vectors graphically as well. All right.
Yeah.
Yeah. So over here, if you have 2B, so basically you do this. Mathematically, 2 times 1, 2, this is 2, 4. So same thing. You need just to this one more time. So you need to give yourself a. So this is 1 unit, and then 2 unit up, right? So it's 1 unit to the right, 2 unit up. So you'll be here, right?
Okay.
So this point is your 2, comma 4 coordinate format, then a column vector 2, 4. Okay.
Okay.
And then now, if you look at it, so if you do it mathematically, addition of vectors, so you have 0, 6, and then plus 2, 4. You will end up with what? 2 and 10, right?
Yeah.
Okay, so 2 and 10. So same thing. I think due to the not really restriction, I think I can. Let's see if I can add in the stuff. I'm just trying to show you how to do it graphically. I hope you understand.
Okay.
Or I hope you can tell also. Can you tell?
Yeah, but
Ah.
I don't see why we would do it like this.
You mean graphically?
Yeah, I think it's simpler to just times the number.
Actually, we need to do it this way because when I don't know whether transformation is the next topic. So when it comes to the transformation chapter, you have a better understanding. If you have knowledge in these vectors. Okay.
Wait,
Yeah.
is transformation the same as translation?
Yeah. Okay. Transformation and
That's my next
translation.
part.
Translation. Okay. So in transformation, right? In transformation, there are different transformations techniques. So one of them I think is translation, and then the other is called enlargement. Okay, and then I cannot reduction or something. I cannot remember all the forms of transformations. Okay, but just to give you a preview. Okay, so in a way, if you just use this graph to get this this 0, 6 and then 2, 4. So how you will do it is, so this is 2 unit, and how many 4 unit, right? So you just 2 unit and 4 unit up, right? So you just get, basically you so called you get this to here. So therefore
Okay.
you can get this.
So just moving all the points.
Yeah. So in a way, that's how you solve it graphically. You see how I solve it graphically? And we use a blue line. Make it, okay, but just to make it can you see?
Yeah.
Yeah. So yes, if you solve it graphically, then you will get this. This is 2. Okay. This is 10. Coordinate 2 and 10. So it's the you solve it faster mathematically, but yeah, you can also solve it graphically. All right. So
Is there a point to show it as a column vector? Isn't it just like isn't it the same as coordinate? I did not just the same thing.
Coordinate. Okay, coordinate is for coordinate. Then vector is direction, and okay, just remember, coordinate is more to the scalar. Is a scalar. So vector is so basically coordinate is just value, no direction. But when it comes to vector, is value plus magnitude. Actually, it's magnitude plus direction. For this, I think we care about the magnitude only.
Okay, but the column vector doesn't show. How does it show direction?
Column vector shows direction. The column vector shows direction when you this. Okay, in fact, this is the okay. This is direction, eh? Okay, you need to show this.
Yeah, but
The
I'm talking
column
about the way
vector.
we write the column vector.
The column vector does not show the direction. In okay, in a way, I don't know whether you can get it is direct. I mean, the column vector itself. Let's say I give you 2. Let's pick this 2 and 9.5, right? In a way, it doesn't have a direction here. But if you really plot it out, so let's say we just do this example: 2 and 9.5. Okay, over here is 2. I will say is too crowded, so let's not do 2 and 9.5. Let's do 2 and 2 and 2.
Okay.
2 and, I mean that column vector 2 and 2 is here, right?
Yeah.
So this is how you represent this 2 and 2. Okay.
But wouldn't the coordinate?
While coordinate, you don't have to show this arrow. You just join the points.
Oh,
Okay.
Yeah. Okay.
Yeah. Okay. But very good questions raised by you. Okay. There is just a subtle difference.
Okay.
Yeah. The subtle difference is there is this direction. Okay.
Okay.
Yeah. So the column vector might, on the surface, it might not tell you the direction, but if you represent it on this x and y axis, then you start to get the direction.
Okay.
All right.
Yeah.
Okay. So I hope by giving you this by putting these two together side by side, you have a better understanding how because otherwise all this addition or subtraction of vectors, right, they look kind of like, what's the use of that in life,
Yeah.
Okay. All right. Okay, good. So next chapter, transformation, then maybe if we need to talk about that, then maybe I can link the transformation chapter later on, when you start to learn about transformation, then I try to link it to this one more time. Okay, to vectors one more time. Okay. All right. Okay, good. Okay, good. So it seems like you have no problem with this. Okay. So you can continue the which part? C, right? Are you doing
No.
or you are still
I haven't done
12?
B because B asks for magnitude, not just the column vector.
So are you doing 12C or B, boy?
12B.
Okay, good. Yeah, please. Okay, so looks like I need to erase the, or maybe you can do it on the left hand side, which is here. Here.
Okay.
Thank you, thank you, thank you. I asked you for whole numbers, right?
Yeah.
Okay, good. Nice. Are you going to have any exams soon or tests?
No, it's after the September. It's like 2 weeks after the September holiday.
Oh, okay.
That's when my final exams start.
You don't have any like small tests before your exam?
No.
Oh,
We
okay.
had one math project and that was it, but it's already done now.
What is the project about?
It's just the differentiation integration. Like it's
Practice?
no, it wasn't a practice. It was like that's the project itself, but it's just a paper.
So you are given some instructions to explore differentiation and integration.
Yeah.
Oh, okay.
It's a group project.
Okay. Have you finished that?
Yeah, finished and submitted.
Okay. All right, yeah, 14. Where you are doing 13? Do I need to pan to somewhere?
Oh yeah. Okay.
Oh.
Should I just erase this or
Yeah, you can,
just move it?
you can. Or you can just move because I can see where your cursor goes. So you just move the picture somewhere to the left or right so that you have blank space and just work on there.
Yeah.
Yeah, good. Hmm. All right. Is your sister in grade in Sec 3 now?
Yeah.
Oh, okay. So you can coach him math.
I don't really do that much.
Oh, okay. Because she doesn't need your help. What?
Yeah.
Oh, okay. She can manage on her own.
Yeah.
Okay, nice. Nice. I'll go and grab a glass of water and come back. Finish.
Oh, wait. Not yet.
Okay, no problem. Can I ask, is Victoria a co-ed school?
No.
Boys school?
Yeah, it's fully
Oh,
boys.
okay. So your school is called what? Victoria JC or something?
Yeah, Victoria JC.
Oh, okay. I think one of my uni friends, I think actually he's one of my best uni friends, and then so he's from this VJC also. Okay, looks good.哦，好，来那边，我这边拍，那边给我就好，我在录我的课，不好意思。对，谢谢你。你收到工资了？啊？收工资了？没。哦，为什么？没开始。哦，22号开始。OK， 好，谢谢你。我等一下发你一个通知，谢谢你。All right. Oh, you have uploaded something else?
It's the next page of this.
Okay, yeah. Sorry, but pen to that. Do you have something more interesting?
For vectors.
Yeah. No.
I mean, we can just go to the next topic. I think these examples are quite.
No. What is your next topic?
The translation. Then after that is application of vectors in geometry.
Actually, we should go to that part. Translation. Yeah, we should go to that part, like the application of vectors and coordinate geometry.
So we're skipping translation.
Okay. Is translation a chapter, on its own?
No, it's like a mini chapter.
Oh, so it's like translation is part of this. Part of your this. I mean, vectors, then translation, and then the application of vectors and coordinate geometry. They are together.
Or everything is in one note, like one.
Oh, okay, good. Then
vectors.
we have to Then we have to talk about translation.
Okay.
Yeah, good. Okay. Actually, yeah, like I say, they are, yeah. If you look at translation by a vector, right? So in a way, they are related somehow, right? Mm-hmm. Right.
Yeah.
So, it's a transformation move every point on the object the same distance in a specified direction. This same distance in a specified direction can be described using a vector. So, okay, use a vector to describe the translation to A, D, D, F. So from here to here. So what's the translation? Yeah. So in a way, you have to understand. So in a way, right? I think the example I showed you just now, like how you can relate how can you can relate vectors to this to the coordinate geometry. You call it the Cartesian what? Cartesian plane or something?
I'm not.
The
Not
X and
sure.
Y axis. The X and Y axis. Okay, never mind. So I'm talking about this one. We call it Cartesian something. Okay, so I think that example, just now I really relate the addition of vectors to how you can also get the results by graphing it out. So I think it's pretty helpful over here, right? So you look at your point A here. Point A is what? -2 and 4, right? All right.
Yeah.
Then your this D point D is what? Okay. Maybe we shouldn't look at what is D, okay, in coordinate geometry system. But I think you can tell that it moved by 2 unit, another 2 unit, another 2 unit, then finally 1 more unit. So it's 2, 2, 2, 1. So it moved how many units? 7 unit to the right?
Yeah.
And then it goes up by 2, right?
Yeah.
Okay. So in a way, this point A is by a column vector. How is it by this is 7, 2. Do you have the answers to it?
No.
Mm-hmm.
Not given the answer.
Mm-hmm. Okay. Never mind. So we just look at point B again. From -5 to 2, right? Here. Let me use this one. So this is 7 unit. It's 2 unit, right? Up, right? Okay. So that's why use a vector to describe. So basically, is I kind of like have forgotten how to describe. I need an example. But the gist, okay, the gist of this is it moves to the right by 7 units, and then and it goes up 2 units, all right, for each of the points, and then you end up so in a way, for your easy understanding, so this is a triangle. Of course you don't do it this way, but for your easy understand, triangle ABC plus this column vector will give you this triangle DF. All right.
Yeah.
Yeah, I have forgotten how to describe it. Okay, let me quickly do a check online.
Okay. Because this is the only page for translation.
How to describe translation or vector translation. Okay, that transformation that most of you can communicate from one to another. So, okay, let me just click on this. Then moves with the tree right into Hold on, just we translate the triangle on the coordinate grid by the vector. There's all the vector that you need. Yeah, I'm right. So basically, you just find out this.
Oh.
Yeah. Basically, you just say the vector to translate. So basically, the vector to translate triangle ABC to triangle DF is 7, 2. Right?
Okay.
Yeah, pretty simple
Is it
stuff.
always described using a column vector?
Yeah. Okay. Oh, wait. Like I say, this is translation only. But when you talk about transformation later, there can be more than one transformation. So what I'm trying to tell you is, they can, let's say your ABC to DEF is by a column vector 7, 2, right?
Okay.
But what about they enlarge this each side? Let's say they enlarge it. I mean, twice it to become let's say I call this XYZ. So therefore, sometimes they will ask you to describe the transformation from ABC to the newly created triangle XYZ. So it involves two transformations, right? The first one is translation of 7, 2, right? Then next is enlargement 2 times, right?
Okay.
Can you see this is x times 2 times 2 times 2?
Yeah.
Yeah. Okay.
You just put like number 2 in front of it.
So basically, you just say the vector to translate this is this. Then DEF to this XYZ is enlargement with a factor 2. 2 means times 2. Half means you half it, or the other way, opposite to it, the negative 2.
How do you when you say a factor 2, is there a way to write it mathematically?
A factor of 2. Actually, when it describe, if you use describe means like you try to mix mathematics with English. Okay, of course, the more the more mathematics, the better, because we are doing mathematics here. Okay, but they ask you to describe, so you have to.
But if they never said describe, how would they write that enlargement?
No. I mean, the only question they can ask is to describe.
Okay.
Okay, so because like let's say I give you this, then suddenly I ask you, how do you get from, let's say this is triangle 1, this is triangle 2. How do you get from triangle 1 to triangle 2? So you need to describe, right? How, right?
Mm-hmm.
So for this for this transformation topic or concepts, you mainly use more English than usual. Okay. All right. Okay, so with this understanding, right, maybe we should attempt example 18.
Okay.
When I say we, maybe you should attempt first. So I will pick it up when you have problems. Yep, this example 18. November 13, O level.
Should I draw this out?
Which one?
This
M equals to
L,
negative
M.
3. But the point is the result of the translation of point L by... No, find the coordinate. But you okay? If it's a 2-mark question, you need to show how you get it.
Okay.
Yeah.
And
If it's a 1-mark question, yes, just so it really depends. If it's 1-mark question, just give the answer. But generally, it's a good practice to it's a good practice to just write down your working. Yeah. Nice. LM. Yeah, pretty easy. Yeah, nice. Just to take note, it's good to give it in or mixed number. I remember during my days I got penalized because this is an improper fraction.
Okay.
So it's good to express it in this or this mixed number. All right. Equation. Yeah. Mm. Yep, good. Then still quite boring, yeah.
What's that?
Which one?
Oh, this is
Okay.
okay.
Just want to spice things up a little bit.
Okay.
Yeah, otherwise it's kind of like boring. You know the funny thing is usually the students cannot take it. when the lesson gets too boring. And right now, even the teacher cannot take it.
Oh, yeah.
Yeah. So so it's too much. Oh, okay. 2 ml. Do you have ml?
No, but I have L and M.
What do you have? You have OL
Have the
and
points.
actually you have OL and OM already.
Oh, then OL.
So yeah, so in a way you
OM.
in a way you can have like this 8 ml. Then you get OL, right? So your OL is 3.2. Then ml is what you need to find. Then OM is this one, right?
3.6.
Yeah. I mean this. Yeah, so in a way your ml is minus 3 minus 6 minus 4, right? Okay. Alright?
Okay.
Yeah, so if you 2 times it, then just 12, then negative 8, right?
Yeah.
Okay. Okay. Oh, actually, I kind of like this kind of question that can test you coordinate geometry, vectors, and translation. Okay, very interesting. Okay, good. All right, so maybe we can take a break.
Okay.
And by the way, if you have some of course, I think I know you don't have any A math or E math, right? To you, it's just math, right?
Yeah.
Okay. So what's your next chapter for A? Sorry. Then how do you differentiate? Like this chapter is what, and that chapter is what? Have you finished kinematics?
Yeah.
Oh, so in that case,
Kinematics was right after integration.
yeah. So in that case, I don't think you have. If I really, I don't think you have anything to learn over there already for A. By the way, kinematics falls under A math, so I don't think you have anything for A math already.
Oh, well, my teacher said the vectors is the last topic.
For A math? Or vectors is for E math. I mean, no. This vector.
It's our last topic. After this, we're gonna go to revision.
Yeah. That's the reason why I say you have nothing for A math. So this is the last chapter for E math. So in a way, both to you is integrated math, right?
Yeah.
Yeah, good. Yeah. So okay, it's okay. We can take a 5-minute break, then we come back in 5 minutes.
Okay.
All right. Yep. See you in 5 minutes.